Hi, this is Swapnil Bharti, and we are at the Open Source Summit in Vancouver, and we have second appearance of Greg.
I happened to walk by at the right time earlier
That
today,
was
right?
really cool, right? And then we sat down, and I wish I had more cameras.
That's fun.
So
Now I get to be the only one on, right?
yeah, I want that either way. So this time your talk was more about security, and you kind of created some buzz also on.
Yeah, I did. I gave a talk on the Spectrum, Meltdown, and now Foreshadow. Security stuff, what it is in general cases, and what the kernel community has response to it, and then a little bit of background on why it was such a big problem. Why we were so grumpy over the Christmas break, why I was grumpy last 2 weeks it's been really hard for me, not the community-wise, and things like that. So I talked about that.
And this is all happening before the release, right?
Yeah, before the release happens.
Yeah, that's what I was thinking, how we can, kind of nip in the bud kind of thing that
It's
they say.
happening, yeah.
And it's from the work is coming from Google?
That tool, yeah, the SYZ bot and SYZ collar. It's I think a team in Munich. I think they're in Munich and Switzerland. They're really good tools guys and really good compiler people, and they've modified tools and they're finding all these bugs. And the problem with these bugs is they create them and they give you, here's the crash, here's the reproducer, and can you fix it? And some of them are they're really hard to fix because they're exercising code paths we never had. And they're stressing the kernel. They're like, okay, let's give it false memory pressure, run it in low memory situations and fake things out, so we'll test all the error paths. And some of the bugs, I mean, even in my code, they're like, these are error paths that nobody's ever hit. And normally if you hit these, it means the machine's on fire. And so we're actually fixing those problems now. So we can work in more reliable situations and things like that, which is great to see. But these are things that no normal person will ever hit.
This is the kernel level, but at the device level, application layer, there can be a lot of issues as well, which you have no control over.
No.
IoT has become a massive use case, and Mirai botnet was kind of infamous, and it's Linux devices. But Microsoft came up with the Sphere OS, and they have at the microcontroller level, they have secured it.
Okay, I haven't seen the whole presentation, but I got the general idea. They've shrunk Linux down and tried to if you reduce the attack surface, it's much better.
Yeah, they have their own certified microcontroller, so it will not run any other code, which is not certified with them.
Okay.
So what I'm saying is, have you tried to work with because you work with the hardware vendors a lot, so that they can also implement some things, so that even if it is nothing to do with kernel, but just to make it secure?
I haven't done much of that in a long time, no. I mean, we did work with that with UEFI. I do work a lot with SoC vendors, but usually it's after the chip has been designed phase. That being said, we've been working with the Intel developers for years. There's usually to be a meeting every year where they put the architects of Intel and the architects of the kernel in the room, no managers, and we yell at each other for a day, which is awesome. They were mad at them, they're mad at us. It's great, it works things out. I've done the same thing with a lot of the ARM developers, designers, and stuff like that. So chip companies are reaching out to us and working on that. But then the problem with chips is the pipeline is 5 to 6 years. So I'll talk to you now, say, okay, that's great, and I won't see the result of that for 6 more years. And by then I forgot about it. But it does take a while, but it is getting better. It's constantly slow, constant, incremental improvements are good, and that's what's happening.
Let's go back to the Spectre and Meltdown for a second. It's not a single flaw, it's a family of, there's so many, on weekly basis, if you watch Hacker News site, you see a lot of, what is the ultimate solution? Do they have to come with the new architecture?
So, I mean, the basic idea is, and actually Linus did talk about it a little while ago, it's processors look ahead and guess what you're going to do in the future. And when you're guessing what you're going to do in the future, you have to simulate that, and that causes side effects. So traditionally, chip designers have said, well, since if I'm wrong, I can just throw away everything and roll back to what I was. In order to achieve quicker speeds and things like that, they weren't trying to restore everything, like restore the state of the caches. So you could actually see things were going on. But all processors were that way, and not all companies were designing things in that same way. So what it is now, hardware designers are now aware of oops, when I am going to speculate in the future, figure this out, that's good to do, but if I'm wrong, I can roll things back and I need to restore all the state. And so they can't take the shortcuts they used to be taking, because it does matter. And they were warned about this a long, long time ago. But a long, long time ago, we weren't worried about, you're only worried about running your code on your machine. You weren't worried about running untrusted kernels that were hosted on a virtual machine. And that's when things get nasty at your kernel level. Traditionally, that's never been there. So for the designers to ignore the warnings a decade ago made sense, because they're like, well, that's not realistic. And these things are really esoteric. So they're continually coming out, and the researchers are doing really cool stuff to figure out different ways to attack this, but actually exploiting that is very, very difficult. And even the exploit is still such a minor one in a way that all they're doing is reading memory at another location and stuff like that, which, to be fair, is a problem. But we have so many other real issues that we've been dealing with too. But then it affects it, so the mitigations actually cause your processors to run slower. And that's something that everybody can see and everybody hurts. I know one major company that uses Linux on the desktop. In order for this last one, they disabled hyperthreading just to make sure that everything was safe. And all of a sudden the engineers were like, wait, my normal workloads, I was doing these number crunching and now it's taking longer. What happened? You just pushed a security update to me. Right. And then they're like, well, I don't care about that thing. Well, yeah, you do care about that, right? So it has a noticeable visible impact when normally security bugs don't. Spectrum Meltdown's a big deal that way.
Right. Anything else you want to touch upon? We covered the security basic one, and we don't want to go to controversial stuff, so we are.
So I will call out. So the way Spectrum Meltdown was originally handled was wrong. Intel siloed us. I've talked about that, but I will call out Intel has learned. So this last problem we had, we worked on this for 4 months together in a embargoed way, and it worked out really well. So Intel's learned and have changed, and ideally we'd be able to work with it all in public, but I understand why we can't. We're just realistic. So they've learned and changed, and people see the benefit of that. If we were working on those 70 patches, worry about it for the last minute and we were siloed, it would have been the same normal huge headache as it was back in January. So things have gotten a lot better, which is great to see.
Which is good to see. Thanks again for the second appearance, and hopefully we'll see you again in a few weeks.
Yeah, I'll be in Scotland for the other conference.
Thank you.
All right, cool.